This is Introduction to the Chain Rule, and this is a James Cook style lesson. And James Cook was the greatest British discoverer. And so this is a discovery sort of way to introduce the chain rule. So suppose I asked you to find the derivative of 2x squared plus 3 squared. So I said prime that. Well, you could, I mean, at some point in calculus, at an early point in calculus, you would FOIL this, and you would have 4x to the fourth plus 12x squared plus 9, and you would say, okay, let's take the derivative with that. Derivative of that, we use the power rule here. And, oh, by the way, pause or fast forward the video if you want to skip ahead or just make a prediction. So we have the power rule. So we have 16x to the third plus 24x plus 0. And what does that equal? Let's look at it. What if we have a common factor here? Well, we definitely have an x that we can factor out. And we have an 8, right? Because the greatest common factor of 16 and 24 is 8. So we have an 8x, and what are we left with? We're left with 2x squared plus 3. So let me take this result we have right here, and I'm gonna throw it up here. And then I'll put an equal sign to equals. So this is kind of interesting, right? We just took the derivative of 2x squared plus 3 squared, and we have this 8x, and we still have this 2x squared, whoops, sorry, we still have this 2x squared plus 3 term. Well, let's take another derivative. Let's take the derivative of x squared, oh, I'm sorry, not x squared, x to the fourth plus 1 raised to the third. So what's the derivative of that? Well, before we make any predictions, let's FOIL it, take the derivative, and factor. And we have x to the fourth plus 1 times x to the fourth plus 1 times x to the fourth plus 1. That's what it means to raise something to a third power. And we're going to take the derivative of that. So let me put some equal signs here. So what do you have? X to the, right? Well, FOILing it right there. That's x to the 8th plus 2x to the 4th. That's these two terms right here. Boom, boom, plus 1. Plus 1 times x to the 4th plus 1. Oh, this is tough, right? Not for us awesome algebraists. So what do we have now? We have x to the, that should go all the way over there, x to the 12th plus the next highest power is going to be x to the 8th. So what do we have for x to the 8th? We have x to the 8th times 1, so there's one of those plus 2 more, that's 3, plus 3, x to the 8th. Fast forward at any moment. You feel like it. What about x to the 4th? We have 1 right there. We have 2 more, plus 3, x to the 4th, plus 1. Okay? So we still have to take the derivative of that. Let's use the power rule. And we have 12x to the 11th plus 24x to the 7th plus 12x to the 3rd. Oh, wow, we have a lot of great common factors to take out here. We have 12x to the 3rd times x to the 8th plus, oh, we took it down to 2x to the 4th plus 1. Okay, just factor that. It shouldn't be too hard. I'm kind of rushing ahead here because I don't want to spend too much time. Rewind if you need to. We have 12x to the 3rd. Oh my gosh, look at this guy right here. That is x to the 8th plus 1 squared. x to the, not x to the 8th, x to the 4th plus 1 squared. Wow, look at this. So let me take this and bring this right up here, because we just found it. We just found the derivative of this polynomial. I'm going to take my, take my black pencil and erase the board. So now the question is, based on these two examples, can we make a prediction? Can we guess what x to the 3rd plus 3, that whole thing to the 4th, prime? What would we guess that would be? And that is the essential, you can use your graphing calculator. You can do this out the long way and FOIL and, well, I'm sorry, FOIL, derive, factor. But I think based on these two examples, you might be able to make a good prediction of where, what this derivative would be. And that is your introduction to the chain rule, James Cook style.